Welcome to Delgado Crypto. My name is Angel, and before I get in this video, I want to quickly add that while the mentioning of cryptocurrency to the general public carries the perception of the trading aspect of cryptocurrency on exchanges, while that is a core function of crypto, the underlying development and technology of crypto, to me, is revolutionary in terms of the future with a combination of currency and computer science. The best possible way to understand these concepts, in my opinion, is instead of figuring out the technology, try to understand the problems the technology is inherently trying to solve. And with that, let's get into the video. The FLR network is a distributed network that runs on the Avalanche Consensus Protocol, adapted to the Federated Byzantine Agreement, and leverages the Ethereum virtual machine. It can then be leveraged as a scaling method for smart contract networks without relying on economic safety mechanisms. The absence of a link between network safety and the native token, the spark, allows the greater flexibility as to how the native token can be used. The Spark-dependent application models provides a blueprint for building applications on the FLR network. This relies on three components. 1, Spark used as collateral. 2, Spark is used to contribute to the FLR time series oracle providing on-chain data estimates. And 3, Spark is used as a participation token in governance schemes. The increasing interest in using smart contract platforms to facilitate decentralized applications has led to an effort to develop new consensus protocols with increased computational throughput. Proof-of-stake protocols, POS, are a family of consensus protocols which leverages economic means to guard against attacks. Specifically, network participants lock their network's native tokens in a staking contract, which they may lose in case of malicious behavior. Thus, the network's safety is proportional to the value of stake committed. This in turn limits the use cases that is possible or desirable to express on a POS-based network. Competing uses for the network's native token, such as decentralized finance, DeFi, can destroy the safety of the networks. The Federated Byzantine Agreement, FBA, is a class of scalable consensus protocols that do not rely on economic mechanisms to secure the network. The FLR network is a new Turing complete smart contract platform based on the Avalanche protocol. That do not rely on economic mechanisms to secure the network. The FLR network is a new Turing complete smart contract platform. That resulting network is scalable, safe, and decentralized. It is freed from the constraints and potential safety conflicts of utilizing economic means to solve the cyber attack, which is the attacker subverts the reputation system of a network service by creating a large number of pseudonym identities and use them to gain a disproportional large influence. FLR exists to solve two key issues. First, that 75% of the value that exists in public blockchain cannot currently be used in a trustless manner with smart contracts. Second, both short-term and long-term consequence, there are potential issues with how scaling is being implemented for smart contract networks today. The majority of the new networks use proof of stake or its variants. These protocols derive network safety from their native token. The immediate issue inherent in proof of stake is that the consensus design doesn't yet safely allow for alternative uses of the native token. If a token holder can obtain a higher yield and with no possibility of slashing by providing collateral to create a stablecoin than they can from staking, then as economic rationalists, they will likely do so. This diverts tokens away from staking and eliminates the safety of the network. A longer-term issue is that as proof-of-stake networks gain usage and the value built on top of it increases, the value of the staking token must increase or network will become unsafe. This is great for investors in the token, but bad for people that want to see decentralization become part of the mainstream way of doing business. Because in order for the token's value that secures the network to rise, capital must be diverted from some other use to buy the token. Taken to the logical endpoint, when smart contract networks using proof of stake were to become the ubiquitous method of doing business, the scale of diversion of capital required from other endeavors just to secure the value built on these networks would make the cost of commerce unfeasibly high. It is extremely unlikely to happen. Proof of stake and variant can scale transactions throughput, but existing implementations can't scale for value. In our opinion, proof of stake is more of a stopgap than a solution. How does FLR solve these issues? FLR is at its core a new way of scaling smart contract platforms that do not link safety with the value of its token. FLR still requires a token for the operations of the network, principally to deter spam transactions. FLR's token is called Spark. Because Spark doesn't have network safety implications, it is well suited to enable the trustless usage of non-Turing complete tokens with smart contracts. At network launch, built on top of FLR, is then a protocol to safely enable a trustless issuance, usage, and redemption of XRP on FLR. This protocol is called FXRP. XRP safely and trustlessly becomes FXRP on FLR, secured by FLR's native token, Spark. XRP now effectively exists on a non-Turing complete network, and once there, trustless interoperability with other networks is feasible, both through interoperability protocols such as Cosmos and Polkadot, or with Ethereum via well-defined bridge protocols. In short, FLR can be used as a smart contract platform for XRP or as a trustless pipeline for XRP to other networks. The general methodology of XRP is extendable to any non-Turing complete token, and the ability to decide which other tokens to support and then extend the means to do so is built into the systems and governance of the network. FLR brings together the value of the non-Turing complete tokens with the transformative power of smart contracts on a network that can scale for value as well as transactional throughput. F assets trustlessly originated from and settled back to each other integrated network. Avoid centralizations and basis risks associated with synthetics. Collateralized by the Spark token, bootstrapped by and benefiting each integrated chains community used with smart contracts on FLR, supercharge the usage and utility of each integrated chain's ecosystem. Aggregation of liquidity from integrated chains creates a proliferation of potential use cases. Bringing each integrated chain together, all on FLR, creates unparalleled opportunities. FLR, as of this time of this recording, supports 4 F assets, which include XRP, Litecoin, Doge, and XLM. FLR's native token, the Spark, is required for spam control at the network level because the safety of the network is not contingent on this token itself. Spark can be used in ways which would be unsafe for other networks. First, Spark can be used as collateral within applications. Second, Spark as a contributor, but not the sole contributor, to an oracle providing on-chain time series data estimates, called the FLR time series oracle. Third, Spark as a governance methodology across all elements that rely on it. These 3 components form the building blocks of a collection of applications that can be built using Spark, termed Spark-dependent applications, SDAs, so as the networks doesn't require staking or computation returns for safety. The FTSO becomes the inflation function for Spark itself. One natural application for the SDA is to enable trustless token representations of non-Turing complete tokens. Indeed, approximately 75% of the value that has emerged in public blockchain is in cryptocurrencies on non-Turing complete blockchains. Spark enables the value represented by these tokens to be used on a scalable smart contract platform in a trustless manner. Once that value is represented trustlessly on FLR, it can then potentially be propagated across other networks through interoperability networks such as Cosmos or Polkadot. Hey, if you made it to the end of the video, thank you so much for watching. If you enjoyed the video, leave a like and subscribe. Also, if you would like to stay up to date on our educational content, we will be posting daily on the channel. Also, click the bell notifications, comment if you would like to see more of specific content ideas, and remember, you can stay connected with us via Twitter at Delgado Crypto. Again, thank you so much for watching. I hope to see you there.